Okay, the next question is specifically asking us, and this is regarding psychrometrics. This is A3T61-A05. Same conditions as before, but now we're asking what is the total amount of heat energy removed from the air by the coil? Seems like a sensible question, right? We want to know the capacity of the coil. How much cooling is it doing? And you can see all the answers are in units of BTUH or BTUs per hour. And this is going to be a calculation based on information we've already calculated in the previous 4 questions. So let's go to a blank screen here on the iPad. So we want to know the BTUH. Well, if I want to know BTUH, I can calculate most of this strictly in terms of units. But the BTUH is going to be equal to our CFM, cubic feet per minute, divided by the specific volume of the leaving air. So I'm going to write here volume of leaving air. We're interested in the leaving air because the leaving air has changed conditions. It's the air that's being cooled, and it tells us about the capacity of the unit, its ability to cool the air. And we're going to have this in terms of BTUs per hour, and that means we have to get rid of this cubic feet per minute and have it converted into cubic feet per hour. So we're going to take all that, we're going to multiply by 60 minutes per hour, 60 minutes per hour. And then of course we got to multiply by our change in enthalpy, our delta H, which is in units of BTUs per pound. So let's put in the numbers that we know. So I'm going to take this all the way down to here. This is going to equal our CFM. Well, our CFM is our airflow, which we already calculated at 16,648 CFM. So we got 16,648 cubic feet per minute. And I'm going to write this differently because cubic feet per minute. And the reason I want that there is because I'm going to show you how units all cancel out until we finally get BTUs per hour. So that's CFM, cubic feet per minute. And that's going to be divided by our volume, which was 13.2, the volume of the leaving air, 13.2 cubic feet per pound. 13.2 cubic feet per pound, right? And that's going to be multiplied by our 60 minutes per hour. And our delta H was given in the original question as 5.4 BTUs per pound. That was one of the given pieces of information, our change in enthalpy of the air. So we have 5.4 BTUs per pound. And now when you multiply this all out, you'll see how you end up with an answer that's going to be in units of BTUs per hour or BTUH. And we can show those cancellations by switching over to purple. I'll show you right now. So first of all, the minutes cancel out because minutes divided by minutes, those go away, right? And the pounds cancel out because pounds divides by pounds here. And the cubic feet cancel out because cubic feet cancels out with cubic feet here. And so you can see how when you multiply this all out, you're going to end up with only 2 variables left, your BTUs per hour, which takes us down to BTUs per hour. So when you do the math, run that through your calculator, I end up calculating 408,644 BTUs per hour. And then we take a look at our question and look for the closest answer. And in this case, the closest answer is going to be, it's going to be D right here, 404,571. Obviously, you're going to pick your closest answer, and this is going to be the correct answer. Let's just confirm that by changing slides. There you go, 404,571 BTUs per hour. We'll go back to our calculations now. And you can take one last look at how we calculated that. It's really a matter of making units do what you want them to do. When I say units, I mean cubic feet, I mean hours, I mean minutes, BTUs, pounds. We want our answer in terms of BTU per hour. And that's the way we multiply it out to cancel out all of those units so that we're left with BTUs per hour. 404,571 BTUs per hour.